Okay, let's unpack this. Think about it. In a world just, well, absolutely drowning in information, how do you actually learn something? Make it stick?
Yeah, that's the challenge, isn't it?
How do you move past just hearing facts to truly understanding them, remembering them, and being able to use them? It's something we all
It
face.
really is. The sheer amount of stuff coming at us, it
Yeah.
can be overwhelming. The critical task isn't just getting the data, but like internalizing it, making it usable.
Exactly. And today we're doing a deep dive into some really thought-provoking source material. It proposes this novel concept to tackle this something called brain page modules.
Right. And a larger framework called learnography.
It lays out a pretty distinct perspective on how our brains might actually acquire and retain knowledge best.
Yeah, this material presents a very specific model. It almost describes the motor science of how this knowledge transfer process works in the brain, according to the source.
So our mission for this deep dive is to really dig into this. We want to understand what these brain page modules are, what learnography is all about, and how this material tries to connect these ideas to, well, neuroscience. We're exploring this author's view on how knowledge is really transferred and retained.
According to this particular source, yeah.
So let's jump right in. The foundations here are brain page modules, sometimes just called brain pages.
Yeah, often just brain pages.
Yeah.
And learnography. How does the source actually define these?
Okay, so the source describes brain pages as a cognitive construct. They're presented as the core unit within this bigger system, learnography.
Right.
And learnography is framed as an approach specifically designed to optimize or improve the brain's natural learning mechanisms.
So it's trying to work with the brain, not against it.
That seems to be the idea. The central concept behind brain pages is creating these structured mental page maps
Yeah.
inside your brain's working mechanism.
Structured mental page maps.
Right. Okay.
Like building organized, navigable maps for knowledge right inside your head.
Yeah, exactly. Not just a storage dump, but like
Eh,
a structured map you can navigate.
Interesting visual.
Right. And the source makes a distinction here that I found, well, pretty striking.
Oh, yeah.
It defines learning as knowledge transfer to the student's brain, but then teaching. It defines teaching as knowledge transfer to the teacher's brain.
Okay, wow. That definitely flips the usual perspective, doesn't it?
It really does.
It puts all the focus on what's actually happening
Mhm.
inside the learner. Does the source explain why it makes that distinction? What's the implication there?
It does try to. The source argues that the main act of teaching, especially, talking, verbal instruction,
Yeah.
it serves more to solidify and transfer knowledge within the teacher's own brain.
Through the act of organizing it, explaining it.
Exactly. And this leads to a pretty surprising claim from the source. It actually states that book-to-brain knowledge transfer is more powerful than teacher-to-student learning transfer.
Whoa, okay. That's a bold statement. More powerful.
Right.
How does the source back that up? I mean, what's the mechanism for this more powerful book-to-brain transfer?
This is where the source introduces the idea of the motor science of knowledge transfer. It involves something it calls laws of learnodynamics.
Motor science, laws of learnodynamics. Okay.
Yeah, the argument is that direct engagement with the source material itself, like reading a book, requires the student's brain to perform specific motor actions in processing the information. Like the act of reading and processing is a motor function for the brain in this context.
Ah, okay. So it's not just passive reception.
Exactly. And this direct interaction, the source claims, creates a more efficient pathway for the student's brain to actively build those internal brain page structures itself.
Rather than receiving information that's already been filtered through a teacher's language and interpretation.
That's the idea presented. It's less about passively receiving and more about actively doing something with the information, even the act of reading, which this source considers a motor process for the brain.
Right. So this brings us to how these brain page modules are supposed to work at a deeper level. The neuroscience angle.
Yeah. The source suggests that brain page learning functions by actively activating different parts of the brain, kind of all at once.
Okay.
When you're engaged in this sort of structured, direct learning, electrical signals are sent across various regions, building and reinforcing those neural pathways. That's the basis for real understanding and remembering.
So the key seems to be activating a wide network, an interconnected system, not just like one specific spot.
Precisely. And brainpage modules, according to the source, are specifically designed to activate as many different parts as possible. It explicitly mentions the hippocampus as being crucial here.
The hippocampus, right. Memory consolidation.
Exactly. And this widespread, integrated activation is what the source claims leads to that deep, lasting, meaningful learning.
Okay, so how is the knowledge itself structured within these brain pages? You mentioned a framework. Sotomov.
Yes, Sotomov. The source suggests knowledge isn't just stored randomly, but it's organized into these fundamental elements or modules in specific brain regions. Sotomov is the acronym for these modules: space, objects, time, instance, module, order, and formatting.
Okay, SOTIMOF. Let's break that down a little. What kind of information fits into each of those categories? Can you give some examples?
Sure. Think of them as the building blocks for any piece of knowledge, like different layers or components on a map. Space could be where something fits conceptually, its location in the knowledge map.
Okay, the context.
Yeah, objects are the things or concepts themselves, the nouns, basically. Time is the temporal aspect when it happened, duration.
Makes sense.
Instance could be specific examples or occurrences of the concept. Module likely refers to subconcepts or related bundles of knowledge.
Like smaller chunks within the bigger topic.
Right. Order is the sequence or the relationship between different elements. And formatting could be how the information is presented visually or perceptually, its qualities. The source suggests the brain stores knowledge using these components.
That helps clarify it. So they're the dimensions or elements that make up a single unit of knowledge. But you mentioned something crucial, the source says. The knowledge page itself isn't stored like a file.
Yes, this is key. The source argues that the full knowledge page isn't like a static thing stored in your memory centers, ready to be just pulled up.
Okay.
Instead, it's dynamically created or modulated in the prefrontal cortex whenever you need it. It's described as a working page.
A working page. So it's built on demand by assembling those Sotomov modules.
That seems to be the model proposed, yeah. Your brain doesn't score a screenshot of the page, but it stores the components, the Sotomov bits, and it knows how to quickly build that page in your prefrontal cortex when you need to think about something or answer a question.
And the source argues this dynamic construction part is why the brain page modular theory is necessary, because it's not about retrieving a static picture, but actively constructing it.
Exactly. It's about dynamically assembling that page from the stored Sotomov modules.
Interesting. So this perspective naturally leads the source to take a pretty critical look at traditional classroom teaching methods, right?
It definitely does. The source views traditional teaching as fundamentally an indirect knowledge transfer process.
Indirect how?
Well, knowledge goes from a source, like a book, into the teacher's brain first. Then the teacher translates it, repackages it using language, and projects it out to the student's brain.
Okay. And the source's claim here is quite pointed, you said.
Yeah, it argues that because of this indirect learning mechanism, most of the learning parts are lost during that teacher-to-student transfer.
Lost. That's a strong word. Does it specify what parts get lost or why the language transfer is claimed to be so, well, inefficient compared to the student engaging directly?
It doesn't list every single lost part, no. But the implication is that the richness, the integrated Sotomov elements, maybe the nuances, and perhaps critically, that motor processing the student needs to do to build their own robust brain pages. That stuff gets diminished or bypassed when information is mainly received passively through listening.
So the active construction part by the student is weakened.
That's the argument. The direct book-to-brain knowledge transfer, where the student applies their own motor knowledge by actively grappling with the source material, is contrasted as the more effective path in this framework.
And this framework even mentions something like a one-day, one-book system.
Yeah, as a potential application, suggesting this kind of focused immersion in a single source helps facilitate that direct transfer.
Right. And the source kind of doubles down on its point about teachers then.
It does. It reiterates that while teachers are obviously central in the current system, their teaching performance primarily serves to solidify their own brain pages. The focus, in this view, needs to shift to the student's direct engagement with the source material, not just what's happening in the student's listening brain during, say, a lecture.
Okay, let's dive deeper into the brain areas the source highlights. The hippocampus and the prefrontal cortex, these seem central.
Absolutely central in this model. The source gives the hippocampus a great analogy. It calls it the search engine of the student's brain.
I love that. A search engine. It makes intuitive sense, right? Like using Google to find info online. The hippocampus is claimed to be responsible for retrieving those stored sodomorph modules.
Yeah, the facts, the concepts, the pathways, the memories,
Yeah.
everything you need to construct that knowledge page. It helps you navigate your internal web of knowledge module.
And the source points out established roles of the hippocampus that fit this, right? Part of the limbic system, crucial for declarative memory, long-term memory consolidation.
Exactly. And it specifically notes the posterior hippocampus for processing spatial memory, which is fascinating because the brain page model talks about knowledge transfer, partly in terms of navigating conceptual space.
Right, connecting that known spatial function to navigating a knowledge map. That's clever. And then there's the prefrontal cortex.
Right, the PFC. As we touched on, this is where, according to the source, that working page of knowledge is actively created or modulated when you need it. It's like the brain's workspace or whiteboard, where it assembles the pieces retrieved by the hippocampus.
Okay, so the dynamic interplay between the two is critical. Hippocampus retrieves the sodomorph building blocks.
And the prefrontal cortex actively constructs the page from them. This interaction is presented as crucial for learning transfer and memory storage, creating these brain page of memory modules that function like cognitive maps for knowledge.
That dynamic assembly process really seems key to this whole model.
Absolutely. So, given all this different way of looking at learning, what does the source see as the potential benefits of actually adopting this brain page module approach?
Well, the source lists several potential big upsides. It claims this approach promotes really deep understanding and long-term retention because it aligns learning with what it describes as the brain's natural working mechanisms.
Okay, deeper learning.
And this, it argues, should lead to better academic performance and help build genuine lifelong learning skills.
Makes sense if the learning is deeper. What else?
It also suggests it fosters more active learning and engagement. The idea is it could potentially make school a more positive, maybe even enjoyable experience, as the source puts it.
More enjoyable learning is always good.
Definitely. And by encouraging organized learning, those structured maps, it claims it can reduce the stress that often comes with just feeling overloaded with information.
Yeah, that feeling of just drowning in facts. Flexibility is mentioned too.
Yes. Flexibility is another claimed benefit. This approach could allow for more individualization, adapting to different learning styles and paces.
So it's not one size fits all.
Ideally not. Ultimately, the goal stated is to optimize the whole process, how students acquire information, how they retain it, and crucially, how they apply it.
And the source mentions feedback being important here.
Very important. It emphasizes that ongoing feedback from educators, from students themselves, even from neuroscientists, is vital for actually developing and refining these brain page concepts.
So it's not presented as a finished product.
No, more like a framework that needs testing and iteration. This feedback loop is seen as crucial to ensure the brain page modules evolve effectively and maybe shape the future of what the source calls learnography and pre-training students.
Pre-training students. What exactly does the source mean by that?
Based on the context, pre-training seems to mean building up the foundational capacity within students' brains to use these brain page mechanisms effectively.
Ah, like training their internal search engine, the hippocampus, and their page constructor, the prefrontal cortex, to work optimally.
Exactly. Sort of making them ready for efficient knowledge transfer before they dive into really complex subjects, preparing the machinery, if you will.
Okay. This connects strongly to another key concept the source highlights, active learning and this idea of the knowledge explorer.
Yes, the source is very clear that just passively receiving information isn't enough. It really emphasizes the need for motor knowledge and active exploration by the student.
Motor knowledge, again, meaning the student has to do something.
Right. Students need to actively explore the objects, the facts, the events related to the material to develop those rich, smart brain pages. This, the source argues, just doesn't happen effectively if it's only motivational talk or traditional teaching, where the teacher is the main one exploring the subject.
The student has to be the explorer. And the source introduces two dimensions of this internal exploration.
Exactly. It describes the learning explorer as the first dimension. This is based on the brain's own working mechanism.
Okay.
It involves navigating the conceptual space, the objects, the modules within that brain page process. The source says this develops in the parietal cortex, drawing on sensory inputs. It's about mapping the territory internally.
So building the map and the second dimension.
That's the knowledge explorer.
Yeah.
This one is generated specifically by question asking in the classroom.
Ah, the student asking questions.
Yes. This active questioning activates working circuits in the student's brain, through participation. The force claims this action launches brainpage learnography. It gets the system going.
Okay, so putting it all together, according to this source, effective learning isn't just information coming in. It's about the student's brain actively, almost physically, exploring the material like a map that's the learning explorer, and then engaging with it critically by asking questions, the knowledge explorer. This active motor engagement is what builds the brain pages.
That seems to be the absolute core mechanism proposed by the author. The student's active construction and navigation are really paramount for learning to actually stick.
So to recap this deep dive then, we've explored this concept of brain page modules, these structured mental maps. They're presented as the core of this learnography framework.
Right.
We've touched on the source's specific and, potentially controversial claim that direct book-to-brain transfer using this motor science of learning might be more powerful than traditional teacher-to-student transfer.
A point that definitely makes you think.
We looked at how these modules are claimed to work, activating different brain regions, organizing knowledge into those Sotomov elements.
Space, objects, time, instance, module, order, formatting.
While the complete page is dynamically built in the prefrontal cortex, with the hippocampus acting like that crucial search engine.
Yeah, retrieving the Sotomov modules.
And we discussed the source's critique of traditional teaching as being indirect, where learning parts are supposedly lost. It contrasts this with learnography's focus on direct, active student engagement.
Through those Learning Explorer and Knowledge Explorer functions inside the student's own brain.
All of this is presented in the source as an approach trying to make learning more effective by aligning it closely with this specific model of how the brain is claimed to actually work.
It certainly gives you a lot to chew on. Very different lens on learning.
It really does. And it leaves us with a thought for you, the listener. If knowledge isn't just passively absorbed, but actively created and navigated, like using a search engine to build maps in your own brain from these structured components, these Sotomov bits, making dynamic pages, how might you change the way you approach learning complex topics? Or even just organizing information in your own life? Something to mull over after this deep dive.